Okay, so this is a video that is really the second day of finding the probability of independent and dependent events. Yesterday we looked at some problems like the warm-up, so everyone take a minute and pause the video and work on these 4 little questions. Okay, so we have 3 problems that are conditional probabilities. The first thing I'm going to do for my problem is I want to kind of find some totals here. So I have 15 reds. I'm going to switch colors. Let's go to purple. I have 15 reds. I have 18 blues. I have 4, 23, 35, and altogether we have 95 marbles. Now if I add up all the small marbles, 10 plus 8 plus 2 plus 20 plus 20 is 60. And I'm just going to double check because this should end up to be 35, but I'm just going to double check it. 10 plus 2 plus 3 plus 15 is 35. Perfect. Okay, so now I'm ready to move on to my problem. So the probability that a marble selected is red, given that it is large. Well, I have 35 large marbles. And of those 35 large marbles, I have 5 that are red. So that fraction will reduce to 1 out of 7. Okay. Small, given that they are blue. I have 18 blue marbles. Of the 18 blue marbles, 8 are small. And that will reduce to 4 ninths. Large, given that it is a green marble. I have 23 green marbles. And of those 23 green marbles, 3 are green. And that doesn't reduce. Right, now, this is not a conditional probability. This is a complement problem. The probability of it not being white. Well, I have 35 white marbles and 95 total. So rather than add up all the other numbers, I'm just going to do 95 minus 35, get 60 out of 95, which reduces to 12 over 19. Okay. So last night's homework was in the textbook. If I were you, I would pause the video and check your answers. You can ask me at lunch on Monday, or you can ask Mr. Z for some help. But here are the answers to last night's homework. Okay, so what we're going to do is we are going to look at a couple problems that deal with independent and dependent events, and then I have some classwork for you, and if you finish early, you can start your homework. All right, first off, I have the probability of some event A is 25%, and the probability of some event B is 75. And I am looking for, and I know that A and B are independent events. If A and B are independent events, find A and B. So first A has to occur, and then B has to occur. So I'm just going to multiply them together, 0.25 times 0.75, and I get, okay. Now the next one says A and B are dependent events. So find A and probability of A and B. So first I'm going to take the probability of A and multiply it times the probability of B given A. And 0.3 times 0.4 is 0.12. Remember, we talked yesterday about the tree diagrams and why we multiply these together. All right, so now number 3 is a little trickier. A and B are dependent events. I know the probability of B given A, and I know the probability of A and B. What I don't know is the probability of A itself. So what I'm going to do is I'm going to set up an equation. The probability of A and B equals the probability of A times the probability of B given A. And I'm going to fill in what I know. I know the probability of A and B together is 0.35. 0.32. There we go. I don't know the probability of A. And I know the probability of B given A is 0.8. So I'm just going to do a little dividing. Divide by 0.8. And and I find that the probability of A is 0.4. Hooray! All right, let's look at a long problem. Okay, so the American Diabetes Association estimates that 5.9% of Americans have diabetes. Suppose that a medical lab has developed a simple diagnostic test for diabetes that is 98% accurate for people who have the disease and 95% accurate for people who do not. If the medical lab gives a test to a randomly selected person, what is the probability it is correct? So what I want to do is, I actually want to do this problem twice. I want to do it using a tree diagram, and then I want to do it just with the formula. So here we go. So here's my person. Now, either this person has diabetes or they don't. Okay. And then, if they have diabetes, they can get a correct diagnosis, which would say, yes, you have diabetes. Or they could get an incorrect diagnosis, which says, no, you do not have diabetes. But in reality, you do. Then we have the person who doesn't have diabetes. They don't have diabetes. And they could get a false positive. So I'm actually going to write that down. False positive. And what that means is the test comes back positive, but they actually don't have it. And then, of course, they don't have diabetes, and it says you don't have diabetes. Right, so these are the four situations. So the diagnosis is correct. I have four branches here. Which branches say the diagnosis is correct? Yeah, right here. You have diabetes, and the test says you have diabetes, and then, you don't have diabetes, and the test says you don't have diabetes. So let's assign some probabilities to these branches. If 9.5% of people, I'm going to write things as decimals, that way my calculations will go smoother. 1 minus that, the complement would be 0.941, they don't have diabetes. Now, if you have diabetes, the test is 98% accurate. That means that it is 2% error, not correct. So these are the false negatives. It is 95% accurate for the people who don't have diabetes. So this gets a 95. And of my people who don't have diabetes, a 5% are going to get a false positive. Okay. So once I've done all that, now I'm going to kind of work on it the second way. When I said I was doing it two ways, I was really just organizing my information. So now this is what's going to happen. Either I have diabetes and get correct diagnosis. I'm going to type this out so it's neater. So this is what I'm looking for. All right. We are looking for the probability that you have diabetes and get the correct diagnosis, or you don't have diabetes and get the correct diagnosis. Okay. It's really important to have the words correct. So now I'm going to split it up. This is going to equal the probability of having diabetes and getting the correct diagnosis. You're really happy that I'm typing now, aren't you? Plus the probability of not having diabetes and get the correct diagnosis. Okay, now we're going to take it a step further. So having diabetes and getting the correct diagnosis, to do that, I'm going to take the probability that you have diabetes, and I'm going to multiply that times the probability that you get the correct diagnosis. Let's just change the color, make that a little easier to see. All right, and get the correct diagnosis, given that you have And we're going to add to that the probability that you don't times the probability that you get the correct diagnosis given that you don't. All right, so here we go. Let's do a little highlighting, shall we? Have diabetes and get the correct diagnosis given that you have. So you have diabetes and you get the correct diagnosis, or, we'll do this one in gray, you don't have diabetes and you get the correct diagnosis that says you don't have diabetes. So here we go. On our calculators, we are going to say 0.059 times 0.98. That will give me the percentage of people who have diabetes and get a correct diagnosis. I'm going to add to that 0.941, which is the probability of not having diabetes, times I get the correct diagnosis of not having diabetes. And once I do that, on my calculator, I get 0.95, and then there's stuff in around to 2. So you have a 92, this test would give a 92 or 95.2% correct diagnosis that you either do or do not have diabetes. I'm just going to pause. People need to catch up. Right. So this was one example of a more complicated conditional probability of dependent events. We're going to look at one more dependent event situation, and then you're going to get started on your classwork. All right. So let's look at 3 dependent events. You and 2 friends go to a restaurant and order a sandwich. The menu has 10 types of sandwich, and each of you is equally likely to order any type. What is the probability that each of you orders a different type? So I'm calling event A your order, event B the first friend's order, and event C the second friend's order. All right? And I want everyone to get a different kind of sandwich. So the first person orders. Then the second person orders, given that the first person has ordered. Then the third person orders, given that the first person orders. So person A goes to the counter, says, I want a sandwich. They have 10 sandwiches to pick from. So the probability of their order, because they have any type they want, is, where's my pen? Pen! Oh. The probability for person number 1, there are 10 choices on the menu. And they have a 10 out of 10 chance. So they're going to order something. Now, let's say they get turkey. Yum. Person B walks up. They know person A has gotten a turkey sandwich. They look at the menu. Here is the trick. Turkey sandwich is still on the menu. The menu still has 10 sandwiches left. But person B says, I do not want a turkey sandwich. Person A got that. I will pick from the 9 sandwiches that are left. So the conditional probability doesn't affect the denominator here, only the numerator, because there's still 10 sandwiches on the menu. But there are only 9 that person B is going to choose from. Person C comes up. Let's say person B had tuna fish. Person A had turkey. Person B had tuna fish. Person C is like, all right, I'm looking at the menu, and I need to order a sandwich. There are still 10 sandwiches on the menu, but I don't want turkey and I don't want tuna because the other person got those. So they look at the 8 sandwiches that are left, and they need to make a decision. When you do all this arithmetic, the numerators come up to be 720. The denominators end up to be 1,000. Kill that. So there is a 72% chance of everyone ordering a different type. What I want you guys to do right now is to pull out 10.5 practice C. And I want you to work on that with a buddy of your choice. When you are done with that and you have checked that, and I'm going to reveal the answers in a minute, Mr. Z has a copy of tonight's homework and he will give that to you. I'm going to put the notes on Edline. There will be worked out solutions for the review in the book on Edline.